Welcome everyone to Zahid's data mining channel in YouTube once again. My name is Zahid Islam and I will be talking about a decision tree algorithm called Explore. So the main thing that we will discuss today is the basic steps of a decision tree algorithm, what really happens when you use a decision tree software to build a decision tree from a data set. What is the mechanism in the background that actually helps the software or helps you to generate the decision tree from a data set. So basic steps of decision tree algorithms, and then we will talk about a new decision tree algorithm called Explore. And this is the full reference to the paper for the decision tree algorithm. It was published in the 27th British National Conference on Databases, BNCOD, in 2010. And here is the link, so you can actually download the paper from this link. Again, if you are facing any problem downloading the paper, please do not hesitate to email me. Now, the very first question, as usual again, is what is a decision tree? It is a tree-like structure that helps you to make a decision, and you can actually collect or you can actually build a decision tree from a data set. What is a data set? A data set is a two-dimensional table like this. In this example data set, we are showing some information about each soccer matches, maybe stored by a soccer club. Maybe this is a data set that is maintained and stored by a soccer club, where they store their soccer match information, and then they analyze the data in order to understand why sometimes they win, sometimes they lose, etc. So here in this example we can see that there are around 12 records. That means like it's a toy data set, like 12 soccer match information. The rows are records and columns are information. For example, for the first match, game ID 1, we can see the venue was home, goalkeeper was Matt, weather was dry, crowd was approximately 20,000, and they lost the match. But if you look at the whole data set, there are some wins and some losses, so they need to understand why sometimes they are winning and sometimes they are losing. If they want to do that, they can actually build a decision tree like this, and they can use any existing decision tree building algorithms like C4.5, C5, CART, REP tree, and so on. So in that case, if they apply a decision tree building algorithm, then they can build a tree like this, where we can see these rectangles are nodes and the ovals are leaves. So what does it mean? If we look at this particular path from this root node of the tree to this first leaf, we can see that the tree is telling us that the data set you gave the tree or the data set that you use to build the tree has the information that whenever they play in the home venue, in the home ground, having Matt as the goalkeeper, they lost the match. And there are two such records, two such incidents, occasions, and in both cases they lost the match. So a decision tree can actually help you to identify the reasons why sometimes they are winning and sometimes they are losing. Say for example, if you look at this, when the venue is home and goalkeeper is Dave instead of Matt, then they are actually winning all the time. They've played 3 such games and in all 3 cases they won. So this can help a coach or the management of the team in order to take a better decision for the next time they are going to play against other team. So now we need to understand, and this is a decision tree. You can apply any existing algorithms and that will actually build a tree like this, but the purpose of this talk today is to understand the basic algorithms, basic steps, what actually happens when it builds a tree like this. Why it chose venue as the root attribute among all other attributes? Because decision trees are built completely automatically without any human intervention. You don't need to have any pre-assumed knowledge or assumption, unlike other traditional data analysis. So how on the earth the decision tree algorithm could pick venue as the root node. So let us explain that. What it does, it first actually calculates the uncertainty in the whole data set. Uncertainty can be calculated by entropy. Entropy is a measure of uncertainty, and it actually applies that entropy formula on the whole data set and calculates the overall uncertainty of the whole data set. By uncertainty, what I mean is that if I, for example, ask you to pick one record randomly and tell me that random record, what will be the result of that random record, what will be the value of the attribute result for that random record, how certain you can be. Let me give an example. If the dataset, if you had a dataset where all of the records did have result value equals 1 or lost one way or the other, then if I asked you, if you pick randomly one record and tell me what will be the value of that, your uncertainty would be 0. You would be completely certain because you know all the records have the same value, so whichever record I pick, it will have the value, same value. If all the records have the value lost, then I randomly pick a record and that value will be lost as well. But when the values are actually not so homogeneous, our kind of distribution is kind of not skewed, flat, then our certainty increases. Entropy calculates that, and a decision tree building algorithm will first calculate that uncertainty in the whole data set, and then what it will do is it will calculate the uncertainty of each attribute one by one in classifying the class attribute. In this case, the class attribute is result, so in classifying the class attribute result. So how it does it, it handles different attributes differently, different types of attributes. For example, some attributes can be categorical, some attribute can be numerical. So venue is a categorical attribute where there are two categories in this case. So it divides the data set into two parts where, see, the records are rearranged. So record 1, then 9, then 4, etc., where all in one side of the data set, all records have the same class, same value for that particular attribute, and on the other side of the data set, all records have the other value or some other same value for the data set. And then within this horizontal segment, it again calculates the entropy of the class value, and it also calculates the entropy of the class value. It is doing that through this equation, and there are many measures of such uncertainty, and then we can calculate the overall uncertainty if the data set is divided based on the attribute venue, the weighted overall uncertainty for venue. Then it is expected that the uncertainty will drop because you are dividing the dataset into two separate segments, and the drop of uncertainty compared to the original uncertainty of the whole dataset is termed as gain. So information gain, because you are dividing the dataset based on one particular attribute, then you are actually gaining some information. Then it will actually calculate the information gain for each and every attribute. For example, it will calculate information gain for attribute goalkeeper, attribute weather, and attribute crowd, and it will try to pick the attribute at the root node of the tree. Say here venue has been picked that way, the attribute that has the highest gain ratio, that drops the uncertainty the most. So in doing that, as I said before, it can divide the data set very easily into number of horizontal segments if the attribute being used at the moment is a categorical attribute. But for example, if the attribute was numerical like crowd, then how do you divide them into 2 or 3 different data sets, because there is no categories in a numerical attribute. So in that case, for dividing the data sets into 2 or 3 different segments, generally decision tree algorithms, they divide them into 2 segments. So it uses a splitting point kind of thing. It uses a splitting point, and the splitting point can be less than 6000 and greater than equal to 6000, or splitting point can be less than 7000 and greater than equal to 7000, and so on. This splitting point can vary. So they actually try all different splitting points and they find out which splitting point gives them the minimum entropy. Now based on that, it then picks the splitting point, and this is how it calculates or it estimates the root attribute. In this particular instance, it found venue to be the best root attribute, and then the data sets are divided. That a data set is divided into two horizontal segments, where in one segment all records have the venue value equals home, and in other segment all records have the venue equals away, and then it repeats the same process on each segment. That is, the same process will be repeated on only this part of the data set and only that part of the data set, assuming as if this is the whole data set, and this is how it generates the other layers of the decision tree building algorithm. Now this is a common decision tree building algorithm. Now the one that we are proposing here is Explore. It is somehow a little bit different. The main differences are as follows. For a numerical attribute, instead of dividing into two different splits, it actually finds or looks for a window. Instead of dividing it, say, less than 6000 and greater than 6000, instead of dividing into those kind of two parts, it actually looks for a window where it finds the best information gain. For example, if we look at this particular window, then we can see that within this particular window all records have the same result value, which is lost. Therefore the entropy or uncertainty within this window, within this segment of the data set, is 0. So if we choose this as a this window as a splitting criteria, as a splitting point, then we would actually reduce the entropy the most. So therefore this is one of their Explore's approach, that it uses window for numerical attributes. And for categorical attributes, instead of calculating the overall entropy when we are considering venue as the attribute and testing its information gain or its entropy, generally traditional techniques calculate the overall entropy by adding the weighted average, by calculating the weighted average of these two segments. But Explore says, no, we are not interested in the overall entropy. As long as one segment of this attribute has a very low entropy, that is all we are asking for. That's all we are wanting. And using this approach, it also then calculates some other things like ultimate gain ratio, etc., and all these things are in detail discussed in the paper. So once all these things are implemented, this will be an example tree that can be obtained from a dataset. Here we are just briefly explaining what it does. For example, it comes up with windows of numerical attributes, say income when it is between 81 and 124, or in this segment we can say income 90 and 99, such things. So it actually finds, it tries to improve information gain as much as possible in every step, and in doing so it looks for windows and only a single value of an attribute. If a single value of an attribute gives a huge information gain, then it will pick that attribute. And then in the paper we also came up with some factors or some issues that can make that can help us to analyze whether our tree Explore trees are getting any better result than the existing techniques. And for example, here we can see that Explore achieves higher grades or higher points than existing techniques. So I suggest maybe it will be a good idea to download the paper from this link. If anybody is facing any problem downloading the paper, please feel free to email me. This is my email address and this is my web link, and this is the full reference of the paper. And then I think it will be a fantastic thing to use Explore. One last thing, we are not suggesting that Explore is better than any existing decision tree algorithms, but it is all different. Thanks for watching.